Okay, so the upper Riemann sum, I'll just write it as SU for upper. That will be the sum from 0 to n. Oh no, sorry, 1 to n, I think is how they do it. F, the upper sum actually, so sup of f on the set xi minus 1 to xi times delta xi, where delta xi equals xi minus 1, and x0 equals a, actually I'll write that the other way, a equals x0, which is less than x1, which is less than x2, etc., 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 less than xn, which is b. So that's the upper Riemann sum on a bounded function f. Likewise, SL is the lower Riemann sum, and that's all the same, except we use inf instead of sup. So in this question here, our function is definitely bounded, and it's 1 when x is irrational, and -1 where x is irrational. Oh, and I should put a little n index here. Yeah. So Sn upper, that'd be the sum, again from 1 to n, sup f, and the set here, if you apply f to any closed interval on the real line, it'll contain infinitely many rationals and irrationals. I suppose technically more irrationals than rationals. The rationals are countable. Anyways, it's infinitely dense. It has rationals and irrationals everywhere. So any continuous closed interval will contain at least a rational and irrational. So it's the sup of the set -1, 1 times delta xi, and that will just equal the sum of delta xi, which will be b minus a. Likewise, Sn lower will be the same thing, 1 to n, inf this time of -1, 1, delta xi, which will equal minus the sum of delta xi, which will equal a minus b. The limit as n goes to infinity of Sn u is independent of n, so it'll just equal b minus a. The limit as n goes to infinity of the lower sum will equal a minus b. Note that the upper sum, limit n goes to infinity Sn upper, will not equal the limit as n goes to infinity Sn lower. Therefore, there's no integration here, because these are supposed to converge to the same limit. So there does not exist a convergent integration for this problem from a to b of f of x dx. Doesn't exist. A trivial case would be when a equals b, but apart from that ridiculous trivial case, doesn't meaningfully exist here. So not Riemann integratable, no convergent integration here, even though the function is bounded